In this session, I will continue with explanations related to route analysis and thematic mapping. Regarding highway traffic assignment, one of the most commonly used thematic maps is the link thematic map. When you click on the themes and then link, you will have the option to apply scale as a single style or classification as select style by grade. First, let's begin by explaining the scale. You can select the columns or data from your link dataset that you want to represent on the thematic map. For instance, let's choose total volume. You can choose your desired color and decide whether you want to display segments with zero traffic volume. The minimum and maximum values here represent the range of the current total volume data displayed in TOVA. By adjusting the width value, you can make the link lines thicker or thinner to represent the data more clearly. Below, the link type filter allows you to decide whether to draw all links or only specific ones. For example, you can choose to draw only the road network, excluding zone connectors, as I've mentioned. Once you've completed these settings, clicking on the Draw button will allow you to create a thematic map of the links proportional to the traffic volume, as shown on the screen. This way, you can easily identify roads with high traffic volume. As you can see, the major road axis with high traffic volume would correspond to this axis, that axis, and this. When you check on the label option and then click Draw button, you can display the selected value from your dataset, which in this case is the traffic volume. This allows you to see the traffic volume values alongside the map. Next, I will explain the classification. To remove the thematic map you created earlier, you can click the Clear button. Now click on the classification option located in the top right corner. Grade-based style allows you to divide the links into as many grades as you want. And you can differentiate them using different colors and line thicknesses to represent the thematic map. For example, you can select total volume in the column data, just as you did for the scale option. Then divide the links into 5 grades and set thickness values arbitrarily, like 1, 3, 5, 7, 10. You can also set the ranges arbitrarily. Make sure to apply the same link type filter by excluding zone connectors. Now, when you click on Draw, as you can see, the thematic map is displayed on the screen. If you want to apply the link drawing on the base layer uniformly and change the color to gray, it will appear as shown below. Similarly, if you wish to view the traffic volume values along with the map, you can select the label option below and then click Draw. When inserting thematic maps into reports or presentation materials, it's common to turn off the node layer in the map control panel and capture the image in this way. This ensures that the thematic map is displayed clearly without any distractions from the node layer. You can apply different colors to each class like this. Next, I will explain the Turn Volume Viewer of the themes menu. To perform Turn Volume Viewer, you need to first check the Include Turn Volume Analysis option when setting the run options in the Highway Traffic Assignment model. After this is checked, you can proceed with the traffic assignment. Since you have already checked the turn volume analysis and completed the traffic assignment, you can access the turn volume view through the main menu, Themes. You can click on Turn Volume and enter the node aid for which you want to view the data. If you're unsure about the node aid you want to check, you can click on the Map button and select the node at the intersection you're interested in. This will provide directional traffic volume information, and you can use the vehicle type selection window to view traffic volume by direction for the chosen vehicle type. Also, if you want to know the turn volume for other nearby intersections, you can see that when you click on the respective nodes. The turn volume window continuously opens, allowing you to view data for various intersections. Up to this point, I have provided explanations about thematic mapping. Next, I will explain Path Analysis menu. At this stage, there are three path analysis functions that we can perform. First, Highway Selected Link Analysis. This part involves analyzing traffic volumes on specific road segments, determining where the traffic originates and where it is headed. Second, zone-to-zone highway path analysis. Here you analyze the paths taken between specific zones. This helps understand how traffic moves from one zone to another within a particular region. Third, area-to-area path analysis. In this segment, you analyze the movement of traffic between different areas, allowing for a broader understanding of regional traffic patterns. Path analysis is commonly used in the process of network calibration or model validation, where observed traffic volumes are aligned with the model-assigned traffic volumes. It is also valuable for analyzing changes in travel patterns due to new road construction projects. For example, it can help analyze how traffic patterns change when new road networks are added, as I mentioned, such as understanding how the introduction of new roads affects the routes travelers take. If you click on Highway Selected Link Analysis, you will see a subwindow. Within this subwindow, you can select the mode of transport in the Select Mode option to view the traffic volume for that specific mode. By clicking the Map button on the right, you can choose either a single link or a continuous link segment on the map. When selecting a continuous link segment, you don't need to select every individual segment. Instead, you can choose separate segments, and TOVA will automatically find the shortest path to connect them. Now, when you click on Search, you can see, as shown on the map, where the traffic using that particular segment originates from and where it's headed. If you want to view only segments with a traffic volume of 100 PCU or more, you can enter 100 in the minimum value field and click Draw below. By checking the Label option and clicking Draw, you can also view the traffic volume values along with the map. To improve visibility, let's simplify the link colors by selecting Single in the right drawing settings. With this setting, you can easily identify that the traffic using this segment starts from one zone and goes to another. If you want to know which trips are using this segment, you can click on Table Odd, and you will see the traffic volumes for each odd pair that uses this segment. By clicking Export, you can export the currently displayed table as a text file. This file can then be imported into Microsoft Excel or another spreadsheet program for further analysis. You can use this data to analyze zone-specific traffic ratios, maximum traffic volumes, and more. Next, I will explain the zone-to-zone highway path analysis. In this analysis, we'll focus on understanding the path used when traveling from Zone A to Zone B. Here are the steps to perform this analysis. Set the display mode to All for the transport mode and use default traffic display conditions. The origin zone you can select on the map by clicking Is and then click Search. Once you click Search, the minimum and maximum values in the bush volume map below will be filled. By clicking Draw, you can view all the paths used for travel from the selected zone to other zones. To take it a step further, you can select a specific destination zone. This will fill the values in the OD volume between destination zones section, allowing you to see the paths used for travel between the selected origin and destination zones and how many individual paths there are. As such, zone-to-zone highway path analysis is divided into three categories: bush network, OD volume map, and path volume map. Next, I will explain area-to-area path analysis. This analysis is an extension of the zone-to-zone path analysis, focusing on analyzing the routes when moving from one specific area to another specific area. It helps you understand the paths and traffic flow between distinct regions or areas. You can select multiple origin and destination areas using polygon draw or area code search. If you're unsure of the area codes, you can easily choose areas by drawing polygons on the map. Select your origin and destination areas using the same method, and then click Search. The minimum and maximum values will be displayed. Click Draw to see which paths are used for travel between the two selected areas. So far, I've explained how route analysis is commonly used in the process of network calibration, error detection, and comparing travel patterns and traffic volumes between pre-implementation and post-implementation phases. I will now provide a brief example to demonstrate how the concepts I've explained can be put into practical use. First, let's add a scenario for post-implementation. Here's how you can do that. Click on Scenario, click Add. Set the project name as New Road. Set the target year to 2018, the same as the base scenario. For this example, let's assume that the base scenario represents the Do Not Project scenario. Next, you can copy the settings from the base scenario to the New Road scenario. Right-click on the 2018 scenario under the base scenario. Select Copy to. Go to the New Road 2018 scenario. Click on OK. Now you can activate the new Road 2018 map window and split the screen into two map windows. Maximize both map windows and synchronize the scale and position for a consistent view. What you are currently seeing is the application of TOVA's basic functions we've learned in the previous session. As we saw in the previous explanation of the link thematic map, the major road axes in this network include the North-South Expressway, national roads, and the Outer Urban Expressway. Now let's use the network data editing feature in the new roads scenario to add a virtual new urban expressway axis. We are demonstrating how to edit the network data by adding a new urban expressway axis. Click on Network in the main menu. Select Network Data Edit. Click on Link, then Add TOVA, and then Start. Click on the starting point of the road. In the Link Properties window, change the link type to 102 Urban Expressway. Set the number of lanes to 2, capacity to 2182, speed to 91.4, if an ID to 7, alpha to 0.48, and beta to 2.4. Click on the next point to create an intersection. Note that we didn't add an interchange ramp configuration at this point, as we are only interested in observing changes in traffic patterns. Now add a ramp connecting the endpoint to the existing road. Specify 2 lanes at the starting point, a capacity of 1000, speed of 46.8, if an ID of 33, alpha of 0.15, and beta of 4. Once you've completed the network editing, you have to run network data inspection before highway traffic assignment. Specify the highways, expressways and ramps. Click Run. Confirm that there are no errors. After ensuring there are no errors, proceed to the next step. In the main menu, go to Parameters and check the highway assignment parameter values. When you copy a scenario, you should also confirm that the parameter values previously saved are copied along with it. Once you've reviewed and confirmed the parameter values, click OK. Here are the steps to execute highway assignment for the new road scenario. In the main menu, click Models, then select Highway Assignment Model. Choose the model type, Origin-Based Assignment. Click Trip Matrix on the left. Select all modes, then click OK. In the Volume Delay Function section, choose each link at the bottom and click OK. In the Run option, check Include Turn Volume Analysis and Include Path Analysis, then click OK. Go to Stopping Criteria and set the relative gap to 10, then click OK. In Output Information, select Overwrite. Since the base scenario's traffic assignment results are already present in the data columns, choose Overwrite and click OK. Click Run and the highway assignment for the new road scenario will be executed. Now you can open the link table in each window and compare the traffic assignment results one by one. But a better way is to export the linked data and open it in Excel and compare it with each other. Now, I will show you an easy way to compare results within TOVA. Click on Table Manager in the main menu. You'll find Vector Operator and Matrix Operator. Choose Vector Operator. Let's proceed with the comparison. Change the data type to link because we want to compare traffic volumes within the link table. In the Select column, check the columns you want to compare. In this case, we'll choose total volume for both scenarios. Now click Run and you'll see the ID, if1, and if2 columns filled with values. The ID represents the link ID. If1 contains the total volume for the base scenario in 2018, and if2 contains the total volume for the new road scenario in 2018. To proceed with the comparison, click the Calculate button. Now you can see the Calculate field window. Choose the location where you want to store the calculation results. In this case, let's select U1. In the expression field, enter the formula for the calculation. I want to subtract the total volume in the new road scenario from the total volume in the base scenario. So your formula is F2 minus F1, and the result will be stored in U1. Now you can click OK to perform the calculation. The result in U1 will indicate the change in traffic volume. If it's a positive value, it means that traffic increased after the new road construction. If it's negative, it means traffic decreased. In other words, if you plot U1 on the map, you can clearly see which sections experience an increase or decrease in traffic volume due to the new road construction. Next, I will show you how to copy the values from the U1 column to the linked data in the new road scenario. Click on Copy User field, then select New Road. Choose the year 2018, change the field name to Total Volume Difference, and click OK. Now close the window and double-click on New Roads Link Data. When you check the rightmost column, you'll see that the Total Volume Difference column has been added. Now we will use the link thematic map to visualize the traffic volume difference. Select Classification, choose Total Volume Difference, set the class to 3. For values less than or equal to -1, use the color blue. Do not draw for values between -1 and 1, and for values greater than 1, use the color red. In the link type filter, exclude zone connector. When you click Draw, you can create a thematic map showing the traffic volume change by road segment due to new road construction. As you can see, the project route is marked in red, indicating an increase, while most of the other urban express routes have decreased in traffic volume. Up to this point, I've explained how to use the vector operator in table management to create visuals that represent which links have experienced an increase or decrease in traffic volume when comparing the scenarios of do and do not project. Now, I will use the path analysis feature to determine where the traffic volume changes have occurred. Before performing an area-to-area highway path analysis, I'll start by analyzing which zone-to-zone travel routes are affected by the new road construction using the Highway Selected Link analysis. Click on Path Analysis in the main menu, then select Highway Selected Link Analysis. Click on the map and choose a specific segment from the new road. Click Search. And exclude values with less than a minimum of 100 PCU. Finally, click Draw. You can see the route starting from this zone, passing through this zone, and reaching that zone that utilizes segments of the project route. Now, to identify which segments have experienced changes in traffic volume, we will perform an area-to-area highway path analysis. Open two scenarios simultaneously. Go to the Area Path Analysis menu. Select the odd area using Polygon Draw and click Search. Exclude values with less than a minimum of 100 PCO. Check the Label option and then click Draw. As you can see, in the scenario without project implementation, the traffic volume on this road decreased when the project was implemented and it became part of the project route. Comparing the traffic volume on this segment, we can observe that it was around 10,590 PCU in the non-project scenario, but it decreased by approximately 839 PCU when the project was implemented. The project route uses around 11,151 PCU on this road segment. Therefore, it appears that this road transitioned from being a non-project route to part of the project route, with a decrease of 9,751 PCU, while the traffic volume difference on the surrounding grid roads indicates a similar transition for other segments. Just as shown earlier, you can use the link thematic map and path analysis functions to compare scenarios between with and without project. Now I will explain network validation, which is also known as network calibration. Network validation is the process of adjusting various model parameters in a transportation model to make sure that the assigned traffic volumes in the model match the observed traffic volumes as closely as possible for the base year. This is done to ensure the model's accuracy and relevance. To perform this step, it's important to know the observed traffic volume values for major roads. Typically, you can obtain these values from the Traffic Volume Statistical Yearbook. In the case of the sample project area, traffic volume surveys are conducted annually. If you cannot access traffic volume data through the Traffic Volume Statistical Yearbook, it is recommended to conduct traffic volume surveys to obtain the observed traffic volume data. I had added a column named viewpoint to the link data, and I input the observed volume obtained from statistical data into this column. For reference, observed volume is vehicle unit, while the assigned volume of the model is passenger car units. Therefore, it is necessary to unify the units for mutual comparison. For example, when you sort the viewpoint column, you find that the observed traffic volume for link ID 64,200 is 99,254 vehicles, while the total assigned volume is 107,095 PSU. I will explain how to convert assigned volumes to vehicle units in an Excel program and compare them with observed volumes using an example. Let's organize this in an Excel program. The observed volume is 99,254 vehicles, and the assigned volume is in PSU, broken down as follows. Passenger cars 76,945, taxis 2974, buses 130, other trucks 8,554, small trucks 6,463, medium trucks 5,995, and large trucks 6,032. The total assigned volume is 107,093 PSU. To convert PSU to vehicles, I can use the passenger car equivalent factor that I entered in the highway assignment in the parameter menu. The passenger car equivalent values are 1 for passenger cars, taxis, and small trucks, 2 for other buses and medium trucks, and 3 for other trucks and large trucks. When you apply these values to convert the assigned volume to vehicle units by vehicle type and sum them up, the total volume becomes 94,307 vehicles. Then, how different the volume of the model is from the observed volume, that is, how much the error is calculated as follows. The formula to calculate the error rate is assigned volume minus observed volume divided by observed volume multiplied by 100. So the error rate between the assigned volume and the observed volume is minus 4.98. To reduce the error rate in model volumes, you can adjust the capacity or speed in the link data, which can help align the traffic volumes at specific locations with observed values. It's worth noting that when you adjust model traffic volumes by modifying the values for specific links, the changes may be smaller than what you initially expected. Therefore, it's recommended to adjust data for entire corridors rather than individual segments. Whenever possible, it's advisable to calibrate alpha and beta values for the same group, which means by FNID, to update the network and ensure network validation. I'll continue explaining the network validation process in the next session.